Hello everybody, so today we're going to be dealing with Trigonometry chapter 22, exercise 22e, question number 14. So this question states that a rhombus has sides of length 10 centimeters. So what is a rhombus? Rhombus is basically a parallelogram, that is a figure in which the opposite angles are equal to each other and the opposite sides are equal to each other, but in a rhombus all the sides are equal to one another, and in this case they are all 10 centimeters each. Now, and the angle between the adjacent sides is 76 degrees. So now you may wonder, what are adjacent sides? Adjacent sides are the ones like these which have a common vertex. So it can be these or these or these, any one of them. Now if you draw a rhombus in the examination like A, B, C, D, now you may wonder which one are we talking about. Are we talking about this adjacent side to be 76 or this or this or this? So basically it doesn't really matter. For simplicity, if we consider this to be 76, then this is going to be 76 too, because they are opposite and the opposite angles are equal to each other. And this is going to be 104 because the adjacent angles add up to 180 degrees in a rhombus. So once we know that, we can move on to the next part of the question, which says that we have to find the length of the longer diagonal of the rhombus. So once they say that diagonal or like radius or like diameter, just draw what they say. So if they said a diagonal, specifically longer, just draw both of the diagonals, and then you might say, oh, this is longer, we can see it. So we're just going to calculate AC and then write the answer as AC. Well, it doesn't really work that way in maths. You have to either prove that AC is greater than BD and then calculate AC, or calculate both of them and then say that, oh, the length of AC is greater than BD, so the answer is the length of AC. The second method is rather better or easier than the first one, because you don't have to prove stuff. But for simplicity, if you want to prove stuff, if you want to prove that AC is greater than BD, then you can prove by using this triangle. So as you know that if I consider this triangle, this is the altitude, because the diagonals bisect each other in a rhombus at 90 degree. That is, they divide each other at 90 degree angles. They're perpendicular to each other. And this is equal to this side because they're all 10 centimeters. So this is the altitude of this isosceles triangle. So it would divide this into two equal parts. So this would be, if this is 76, then this would be 38 and this would be 38. So likewise, in this triangle, this is 38 and this would be 52. That would be 104 that we calculated before, divided by 2, because this is 52 and this is 52 too. So once you know that, you can draw, I don't want you to draw, but I'm just for explanation purposes. This is 90, this is 52, and this is 38. So we know for a matter of fact that the largest angle has the longest side opposite to it. So this side is the longest, this side is the second longest, and this side is the third longest. So if angle O is the greatest angle, then AB is the greatest side, and if B is the second largest angle, then AO is the second largest side, and then following that would be BO. So from here we can say that AO is greater than BO. So AO is equal to AC upon 2 and BO is equal to BD upon 2. So from here we can say that AC upon 2 is greater than BD upon 2. So AC is greater than BD. And once we prove that, you can just calculate AC from here and then just say that the length of AC is this and the answer is this. So if we're following the other method, so we have to calculate AO and BO and then calculate AC and then just give the answer. So let's start. So we'll start with, in triangle AOB, angle BOA is a right angle. So always tell that it's a right angle so that you can use trigonometry after that. So once you say that, you can just write it on here, and always write SOHCAHTOA because it helps you not to mess up in the examination. Now, from this figure, we can calculate BO by looking at this. If this is theta and this is hypotenuse, then we can calculate the opposite by using H and O, so we're going to be using sine. We will say sine 38 degrees is equal to opposite upon adjacent, that would be BO upon BA. That would give us BO upon 10, and that would give us the value of BO as around 6.16 centimeters. Once you have that, you can calculate the same for AO. You can say that, but here we're going to be using cos because we have to find the adjacent and we know the hypotenuse. So cos from here, cos 38 degrees is equal to adjacent, that is AO, upon hypotenuse, that is BA. That would give us AO upon 10. That would give us the value of AO as 7.88 centimeters. Now once you have that, you can say that AO is greater than BO. So 2AO is greater than 2BO, and 2AO is equal to AC is greater than 2BO is equal to BT, because the diagonals of a rhombus bisect each other. Once you know that AC is greater than BD, you can say that AC is the longer diagonal. And once you know that, you can say that AC is equal to 2AO is equal to 2 into 7.88. That would give you the value of AC as 15.76 centimeters, and that's the answer. So you can say that answer is approximately equal to 15.76 centimeters. And that's it. Thank you.